Hello, this is CAE2 cursor in the MP module. Here we have a reduction gearbox with two gears with different number of tooth, with two driving shaft, few bearings, lip seal, and a casing. Please download the CAD file from Moodle and observe the solution of the general assembly and detailed drawing of the few parts, and then prepare the general assembly and the detailed drawing similar to the solution. So in this part I'm going to show you how to create a exploded view, so you would be able to see the parts, how the parts are assembled together in this gearbox. Okay, so first here we have the assembly file that you need to create it and assemble components together to have such a assembled file. And as you can see, when we rotate this drive shaft, the input drive shaft, the output drive shaft rotate as well. So this is the deliverable result that you have to submit. So now I want to show you the exploded view of this gearbox, and then you will find out how the parts are sit and mounted together. To create the exploded view, first you have to click the exploded view on the toolbar, and then start to select all the components that has to be disassembled together. So first, at the first step, I'm going to select all the bolts on the gearbox. So make sure to select all these screws, head cap screws. Okay, after we select all, then we can drag this arrow and then pull them out from the assembly, and later you would be able to adjust the distance of the parts from the casing. Okay, after you've done this action, you can click on OK. So to find the details of the exploded view, you can go to the configuration manager and you can find the exploded view here. So if you want to edit your exploded view, you just click on that and edit feature. Okay, so I'm going to continue to disassemble other parts from this gearbox. Okay, so next I have to disassemble the end cap and the lip seal, which is already inserted into the end cap. The lip seal in the tree is with the part number of P014. So I have selected these two parts and then I drag them out. So as you can see, the lip seal is already inserted into the end cap, and then I can remove the lip seal from the end cap. Okay, next we can disassemble the lid. Okay, As you can see, when we are disassembling the parts, in every step the steps are recorded here. Even if you want to change the sequence of a step, you can just drag one of the steps and then place in other. So as you can see, we could able to change the sequence of the step, but it's better to return it back to the original place. So 1 2 3, and if you want to adjust the distance of the part from the casing, again you can select the step and then adjust the distance. For example, I want to adjust step 2 and step 3. Okay, and let me adjust step 4. Okay, next we can dismantle the two bearing on the driving shafts. Okay, so I will select these two bearing and then pull them out. Let me close this. Okay. And next we can disassemble the driving shafts. Now we have to disassemble or open up this screw at the another end cap. So let me edit the feature and then select these screws, and then we have to pull them out from this side. And again here we have an end cap which another lip seal is enclosed. Another lip seal has been placed into this end cap. So let me select the end cap, and from here I will select the lip seal with part number of PO13. Okay, so as you can see here, the lip seal has been mounted into this end cap. Okay, next we can remove the bearings. Actually, you could remove the bearing after you disassemble the drive shaft, or if you like later you can change the sequence of the step. It's up to you. So I can change the bearings and then pull them out. Okay, if you don't want that the parts again be touch each other, maybe you can just again adjust the distance of the steps. Okay, so this is our exploded view. Oh, okay, I forgot to disassemble these two parts here. We have two pins on the casing. You can take them out, the pin, and the last part here is a gasket, and also there is two screw here, hexagonal hex cap screw for the purpose of uh, the filling oil to the gearbox. So this is for filling up or topping up the oil, and this cap is for changing the oil. So I think we have already disassembled all the parts. Okay, so I press OK, and our explode view is ready. So you can go to the feature manager and then right click on the assembly part, and then you can click on the collapse. So as you can see, when you click on the collapse, you have again the assemble uh, assembled parts, and again you can repeat this action, but this time click on explode. Okay, also you are able to make an animation from your exploded view. You can click on animate explode. Okay, you can increase the speed of the disassemble or reduce, or you can repeat it, and even you can save the animation for the purpose of demonstration. Okay, so please reverse back this process of assembly to create the assemble file by using the parts provided for you in Moodle. Okay, next you have to you need to prepare a general assembly of this gearbox, similar what you did in CAE1 coursework. The only difference between this practice, this coursework and the CAE1 is that in CAE1 we show everything inside one sheet. If you have many number of details and view, and you are not able to fit all views and detail in one sheet, similar to Excel, you can add an extra sheet to a drawing file. Okay, so you can have more than one sheet in a single drawing file. So when you want to add another sheet, you can just click on add sheet. Okay, and then here on the when this windows pop up, click on the browse and select the location that you have saved your template. Okay, you have to find your template, the location that you saved the template in. You download it from the Moodle, and then for example, I want to select a A2 paper landscape. And click OK. So here I have a A2 paper landscape with our template. And then you can also edit sheet, and even you can add your name to the drawing. Okay, or you may delete the sheet. And the other part of this general assembly is just similar to what you did in CAE1. So please follow the solution and complete this general assembly. Okay. Next, you need to draw a driving shaft, detailed drawing of the driving shaft with a table of the details of the gear, including number of gear, the module, the pressure angle, so that I will talk more about these details later in the gear topic. Okay, so please prepare this uh, detailed drawing. And a detailed drawing for the gearbox casing. Again, as you can see in this detailed drawing, we have two sheets because we couldn't place all the view and details in one sheet. Okay, there are some features that I want to show you in some extra features and annotation that I want to show you in this detailed drawing. Okay, one of the annotation that we are going to add to this detailed drawing is datum and geometric tolerance. Datum and geometric tolerance. Okay, first of all, the location of the pins, you can indicate the location of the pins by using the tool or annotation in insert menu, then go to the annotation and select door pin simple, and then select the location of the pin. Wherever you have any pin, you can select the location of the pin. Okay. Next, we want to see how we can show the datum lines or the datum edge. By using the datum feature, we can place a flag of the datum on any surface or any edge of the workpiece. Okay, normally when we start to place a datum, we start with the alphabet of A, and which is the primary datum, and then the second one with the alphabet of B, which is the secondary datum, and third one with the alphabet of C, which is tertiary datum. So normally for every workpiece we have to indicate three datum, the primary, secondary, and tertiary datum on each workpiece. And later for the machining or any other manufacturing process, we can use this datum to design a fixture for the part. Okay, so let me do. Okay, so for example, this is the datum A, because I have already used datums. Okay, you can select this surface as datum A, and I edit it. Okay, and then another surface as datum B, and another surface as datum C. Okay, so this is just as an example how we can select the datum edge of the workpiece. The next feature that I want to show you is the geometric tolerance. Okay, the geometric tolerance indicates that the tolerance of um, geometrical features. For example, this symbol we call it the position geometric tolerance, that shows the center of this hole with respect to the datum C can move around in a cylinder with the radius of 0.05 millimeter. So the radius of this hole with respect to datum C, it can move around uh, inside the cylinder with this radius. So that's the geometrical tolerance for the position of this hole. Again, this is a geometric tolerance for the position of this hole, and here we have a flatness geometric tolerance for this surface. So this surface could be placed between two parallel surfaces with a distance of 0.1 millimeter. So every geometric tolerance has a meaning. For example, here this geometric tolerance shows the angle of the shaft housing with respect to the surface A, which is actually surface A is this surface. So that means uh, this housing of the bearing should be perpendicular to this datum with tolerance of 0, because it is very important for the bearing to have a perpendicular axis to the casing, to avoid any misalignment in the bearing which cause failure and short life of bearing. So that's really important. So, okay, to use this geometric feature, first what we can do, for example, I want to show the distance between the center of this hole with respect to this edge. Okay, so I select the center of this hole and then show the distance first. Next, I will select the geometric tolerance, and then I will select the type of geometric tolerance that I want to add to this dimension. So I will select the position symbol and then the tolerance, which is 0.05 millimeter, and then you can add the symbol of the geometry, and then you can select that this dimension is respect to which one of the datum. Is it toward the primary, secondary, or tertiary? Okay, in this case, this hole is with respect to datum C. You can also add secondary datum for this position and the tertiary, and then press OK. So you can also adjust the location of this dimension and the geometric tolerance. For another case, let me delete this one. Actually, for this hole, because it's a housing of bearing, it's very important to set the fit tolerance of the housing, because we need a transition. We need a interference fit for the location of the bearing into the housing. So I select the geometry of this housing, and then next I want to add the geometric tolerance for this house. Okay, so the geometric tolerance that I want to choose is perpendicular. Then the tolerance is 0 with respect to datum A, and also you can add the geometer symbol to this geometric tolerance. You can also drag the geometric tolerance and then place it here. Okay, so as you can see, similar to this hole, we have the fit tolerance. You can also add the fit tolerance to dimension of the housing. So here you can choose the fit with the tolerance, and then the tolerance that we need is for this hole is H7. You can also put parentheses around the tolerance and then press OK. Okay, another feature that I want to show you is hole callout. If you use the function of hole wizard in modeling of the, for example here, the casing. Let me show you the casing. To generate the holes here, we have used the hole wizard function, this function. So if we use this function to generate the hole, later we have easier job to indicate the dimension of the hole, including diameter, the thread size, and even the depths and lengths of the hole. So as you can see here, let me show you that we have, for example, for this hole, if we see the features of this hole, it's a straight tap hole with the depth of 8.4 millimeter, and the length of the thread is 6 millimeter. Okay, and as you can see, we have 10 number of hole, and we have 10 hole with this similar feature. So when we use the hole wizard to make the hole and the casing, we have easier job when we want to indicate the dimension of the hole. Okay, for example, here I choose the hole callout and select this hole. So as you can see, we have all detail of the hole, the number of hole, the diameter of the hole, which is M5, and this is the root. This is the thread diameter, the root diameter, and the depth of the hole and the length of the thread. And for example, if we had the through hole here, instead of this symbol, we had the through. It's written through. Okay, next for the other hole that we have for the pin, again we can use hole callout to indicate the number and dimension of the hole. Okay, so as you can see, we have two pins with a diameter of 5, and because we are going to insert a pin inside this hole, again the fit tolerance is important. So what you can do, you can just indicate the fit tolerance again, H7 for the hole, and then press OK. So we have the number of the hole, the diameter, the tolerance, and this is the depth of the hole. It's a blind hole with the length or depth of 5 mm. So this is very important to use hole wizard during modeling. Maybe you need to put more effort if you want to use hole wizard to set location and to set our parameters of the hole, but you can make your job easier later on to generate the drawing. Okay, so I have covered the geometric tolerance, the datum, and the whole column. The other feature and annotation is just similar what you had in CAE1. So again, you need to create 2 sheets to show all details, and you can see again we have this call out for this for hole at the back end plate. Okay, so if you face a problem to use of the hole call out, let me show you something. If for example I go to the file location and then here I select the hole callout. Sometimes you may face this problem, hole callout format file. Okay, if I delete this path or this directory, okay, and then I delete this. So for now, if I want to use the whole callout, you will see what will happen. Yeah, it is still working because I didn't close the SolidWorks. So maybe you will face a message or error that the SolidWorks is not able to find the whole callout txt file. So if you face that message, you can just go to the option, to the file location, and then select the whole callout feature, and then here you need to add the directory of you should go to my computer, directory C, program file, SolidWorks, and the folder is either inside SolidWorks or SolidWorks number 2. You have to be able to find the folder named Lang and then English. This folder is either inside the SolidWorks folder or SolidWorks 2. Okay, select the folder, program file, SolidWorks Corp, SolidWorks 2, Lang and English. So press OK. Okay, so please prepare this detailed drawing of the casing, the drive shaft, and the assembly drawing. Please make sure to prepare all details. If you need to create the second sheet, do it, and then get marked during the CAE session. So the deliverable part is the assembly part, the general assembly, and detailed drawing of the casing and shaft drive. Okay, thank you very much.